Sorry that I was late because I just finished a class in the North Campus. So maybe you can start working on question number 4 in the example worksheet 4. No. When you have a sample, if you want, so for example, the sample size 100, you have 100 numbers, 100 squares of the tree, and then you can show this way, this 100 squares, the n is the front. And then how do you draw this this 100 squares? You have this in there, the scores from 0 to 100, maybe 0 to 10, 20 to 20, and so on. You count the number of things that the score point equal to the but we can because of frequency only. And if you understand something equal to something, you divide it by something. Frequency must have something to give you the sense. So that the total area is all we want. This is just to ensure that area and all the categories. One is the overall. 100%. All the regular categories are 100%. So that's the reason why actually the width of the block, which is the length of the vehicle.
Isn't that an example to divide by that?
I mean, this is how we construct this. We want to show the 100 block. We reckon the 100 block of block use this to sense how many blocks score point and this area should be proportional to the number.
Yeah.
You have more people who invest, you have a larger
Yeah. Yeah.
So this area also is usually for a histogram, you use the area of the sample or portion of the sample area. So the area of this block is equal to the proportion. It is equal to the frequency divided by sample size. The frequency divided by sample size is equal to proportion. So the area is equal to and what is the height of the rectangular block? It is equal to the area divided by the width of the rectangle. The height of this answer. So you divide the area by the width, that will give the height. So that's why the height of the histogram is divided by this proportion. Divided by the width, that will give the height of the rectangle. Okay, maybe I explain a little bit about the histogram. Now, in drawing a histogram, one thing you need to keep in mind is that a histogram is formed by a rectangular box, all put together to show the data distribution. So, how do we draw the histogram? First, according to your data, we partition it into different classes, intervals. So we have A1, A2, A3, A4, up to, depending on the number of intervals we partition. After that, we count the number of observations falling in each of the intervals, which is our VK. VK is our frequency, the count. Counting the number of data in your sample falling in this interval. Now, one very important feature of the histogram is that the area of the histogram must be directly proportional to the count. So the area of this will be directly proportional to the count VK. Now it depends on whether you are constructing a frequency histogram or a density histogram. Usually if we construct a density histogram, the area here will be the count divided by the sample size, n. So VK divided by n will be the proportion or the percentage of observation falling in this class. So that the whole area of all the block add together become 1. Okay? So this is why we divide by n. Now this is not the n because this VK divided by N only gives you the area of the rectangle. And if you want to determine the height of the rectangle, which is the vertical scale in this histogram, the height of the rectangle multiplied to the width of the class will give you the area. So in other words, you divide the area by the width of the class interval, that will give you the height. So that's why histogram of S is given by VK divided by NH. So this is how this formula is produced. When you construct a density histogram, how to determine the height of the rectangular block, we went from a class to this calculation. Okay? Understand? And this question is based on this formula. Okay? We substitute this into this, do the integration, we will obtain this. Maybe I will write down one more step so that you will see how we can get this result. So how we can simplify this integral? We know that this integral is equal to integral from A1 to A2. Add to the integral from A2 to A3. We just partition them according to the subintervals. Okay. An integral can be partitioned into the sum of integral over the subintervals. This is a feature of integration. Now, we can simplify this into summation form. So we may write this into this form. Okay? Each of these will be the term here, and then we take the sum with the subscript k starting from 1 up to k. Now in this expression, we are talking about those x within this particular class. For the histogram of x within this class, according to the formula I just explained, according to this formula I just explained, it will be equal to Vk divided by n times h and then ds. So the idea is that we first have a whole interval and then we partition it into sum of integral over subintervals corresponding to the class intervals. And within each class interval, we know that the histogram of the value of x will be expressed as the count divided by the sample size and also the width of the interval. And this quantity does not involve x, so it can be taken out of the integral sign. So that each of these terms will be just an integral of x, and we know how to, I guess all of you know how to do this integration. The integral of x will be square of x divided by 2. evaluated from AK to AK plus 1, because these are the input limits. So we substitute AK plus 1 into this, substitute AK in this, and get the difference. Now this is not exactly the result that we are asked to prove. So we need to further simplify it. And we can observe that it is actually the difference between two squares. So if you still remember the formula for this algebraic operation, the difference between two squares is equal to the sum of them multiplied the difference of them. This is a formula for the difference between two squares. Okay? A squared minus b squared is equal to a plus b multiplied to a minus b. Sorry, this is h. Now, what are the AK and AK plus 1? They are the lower limit and the upper limit of a class interval. And we know that this class interval has a length equal to h. So that this difference is equal to h. So this h and this h will cancel each other. And what we will just do n here. So this is how we prove this result. Okay? Now, of course, this relies on your knowledge in the quantity. Okay? So this relies on your understanding on the meaning of this quantity. The density that we determined by using a histogram is equal to the count in that class interval divided by the sample size divided by the width of the class interval for any x fall within this class interval. Okay. Is there any question? Okay, maybe you can, based on this result, try to complete question number part 2, part 3, part 4, and part 5 in this question, but they are pretty difficult, so I'm not going to go through, ask you to do it now. Maybe when you go home, you try to think about them. If you encounter any problem, this time you ask me. So maybe now you can try to work on question number 5, maybe. is so for the quartile, the lower quartile is from 20 to 25. No, the same. Now, this is one way to find the quartile. Some other people will find the quartile. Just opportunity to pass, and then based on this lower part of the opportunity to pass and you just but then you not exactly the same.
Is that how you do it?
And for the medium, yes, correct. Usually this and this is the same. For me, Okay, I have seen that some of you have got the answer. Now, I just want to walk you through the details that if you are asked to find the 5 number summaries with a given data set, if you are not using the computer, how can we find the 5 number summary? Now, first of all, you need to know what are the 5 number summaries. The 5 number summaries include the minimum, which is the first order statistic, the smallest number in the data set. And because the data set has been already sorted, so we can easily observe that the minimum is 31. Next, we need to find the lower quartile. The lower quartile is also the 0.25 quantile. So this is the next 5 number summary, and it is equal to Q 0.25. Now, for in general, how we can find a quantile? In general, for a P quantile, according to the formula given in the lecture in this course, first we need to find the index R, which is equal to the A plus 1 multiplied to P. A is the sample size. P is the P here for the P quantile. So in this question, when P is equal to 0.25, N plus 1 times P is equal to 18 plus 1 times 0.25. Equal to 4.75. So the index for us to find the 0.25 quantile or the lower quartile is the number which is at the 4th position, between the 4th and the 5th position in the data set. And it can be done by using interpolation, using this formula. First, we take the integer part of this index. The integer part of R is equal to 4, which is this part. So we take the 4th smallest number here. So Q is equal to the 4th smallest number, which is the integer part. This 4 is determined according to the integer part of this index. Add to the fractional part, which is 0.75. R minus R prime is the fractional part of the index, which is 0.25. Multiply to the difference between the 5th number and the 4th smallest number. Okay. Because this will give us a number between the 4th smallest number and the 5th smallest number with a distance proportional to 0.75, which is the fractional part of the index. So from the data set, we find that the 4th smallest number is 69, which is this one. This one. And the 5th smallest number is 7. So we have 69 here, 0.75 times 70 minus 69. So this will give us 69.75. So this is how we obtain the lower quartile for this question. And for the median, for the next 5 number summary, we also need to determine the median. The median, depending on the sample size is odd or even. If it is odd, it is equal to n, the index will be n plus 1 divided by 2. If it is even, it will be equal to the average of the 2 middle numbers. So this is how we determine the median. So it is equal to 77, add to 79, divided by 2, equal to 78. The average of the 2 middle numbers when we have the sample with the size being an even number. If the n is an odd number, then that will be the number right at the middle. And for the upper quartile, it is the 0.75 quantile. So the index will be equal to 14.25. We add 1 to the sample size, multiply to the p, we get the index for the upper quartile. So that the upper quartile will be obtained as the number which is at the rank 14 in the data set. Add to the fractional part of the index, which is 0.25, multiply to the difference between the 14th number and the 15th number. So we count, we just simply do the simple counting. The 10th number here, 11, 12, 13, and 14, and 15. So there will be 18, 83, and 87. And it will be equal to 80. Oh, sorry. This is the 9th number. The 10, 11, 12, 13, 14, 14 and 15, 87 and 88. So this is how we get the upper quartile. And finally, to complete the 5-number summary, we need the maximum, which is the largest number in the data set. And in this data set, the largest number is 94. So the 5-number summary will be the minimum, the lower quartile, the median, the upper quartile, and the maximum. Okay. And I guess in the previous lab, you had already tried to use a command in R to compute the 5-number summary. But you'll see that some may wonder why we have the type 7, type equal to 7, and type equal to 6. Now, type equal to 7 is the way we compute this 5-number summary. If you use type equal to 6, type equal to 7 will give you another set of numbers, slightly different from this. But if you use type equal to 6, and that will be the way we compute this 5-number summary. Because in calculating the quantile, there are different formulas. Okay? And this is just one of the various formulas to compute the index or compute the quantile. And this is corresponding to the R option in the quantile option, type equal to 7. If you use other type, then the R will use other formula to compute the index, so that the result will be produced will be slightly different from here. Okay? Is there any question? Now in part 2 asks us to use the result of part 1 to produce a plot for this data. Now a plot is just a graphical display, summarize the data based on the 5-number summary. To construct the box plot, you just need the 5-number summary. But usually, before we directly draw the box, we need to first determine the possible outliers. Okay? How can we determine the outliers? We compute the 2 thresholds. So the first step is to determine the interquartile range. Interquartile range is the difference between the upper quartile and the lower quartile. Okay. So this is how we compute the interquartile weight. Interquartile weight is the distance from the lower quartile to the upper quartile. The difference between them gives you the interquartile weight. Then we have the threshold for determining the outlier. So we have two thresholds. The lower threshold is equal to the lower quartile, 0.25 quantile, minus 1.5 multiplied to the interquartile weight. So in this question, it is equal to 69.75 minus 1.5 multiplied to 17.5, which is equal to 43.5. So it is, the meaning of this is that we use the interquartile range to take a distance which is already far from the lower quartile, which is 1.5 times the interquartile range lower than the lower quartile. And if you have an observation even lower than this threshold, that will be a suspected outlier. So any number smaller than this will be regarded as an outlier. And similarly, we also have the upper threshold, which is the upper quartile, plus 1.5 times the interquartile range, which is equal to 87.25 add to 1.5 multiplied to 17.5. So the meaning of this is that this is a number that is already far above the upper quartile. 1.5 times the interquartile range above the upper quartile. So if you have a number that is higher than this, that will be also regarded as an outlier. So to draw the box plot, we will consider this outlier first. We particularly plot them in the board, indicate them in the box plot if we detect these outliers. So in this question, we find that we have two outliers. We have two numbers, 31 and 42. They are smaller than the lower threshold for the outliers. So these two numbers are smaller than 43.5. So in drawing the box plot, you need to take into account this.